Okay, we are going to lump 2.1 and 2.2 notes all together because this will be totally review for you guys. And this is linear inequalities. And this is just going back just to like solving linear equations. We're going to use linear inequalities too, meaning if I graph these inequalities, they're going to make a line. Definition: inequality is a mathematical sentence that compares expressions. It's a comparison. It's a comparison. Inequality symbols. I'm going to make a little chart here. This is going to be my symbol. In the top, I will have key phrases below. Here's my symbols. Hopefully we recognize that. Back from probably 5th grade on, this, you know, is less than. You will also see it described as is fewer than. Totally review, less than. I always remembered it. Makes an L with my hand right here. That is less than. If I trace that symbol, that's it. L is less than. I've got the opposite of that, which is that, which is greater than. If it's is fewer than, the opposite of that is more than. Then it gets a little amped up here, but I add this sign underneath here. Less than, does anybody remember? Or equal to. So this is less than or equal to. You will also see this described. Is at most. Is no more than. These two can be a little tricky. Is at most and is no more. When I'm describing these, I'm always going to think of it as money. If I have at most $20 in my wallet, think about it, $20 at most in my wallet. I don't got over 20 bucks, I got less than. But when we see this most and no more than, we tend to think greater than. Don't fall into that trap. Put yourself an example every time. And again, I'm going to use money. If my bank account is no more than $100, then I certainly don't have over $100. I have less than $100. On the flip side, I have that symbol there. And hopefully you can tell me that is greater than or equal to. If this one was less than is at most, this is at least. If this is no more than, this is no less than. And again, this is where students get tripped up, because you will see in a real life problem describing it, it will say it is at least this amount. If the money in my pocket is at least $20, then I could have over that $20 in my pocket. And what people get confused is they see this least and this less, and they think it's a less than symbol. It is not. They see more and most. They think, it's got to be greater. It is not. Do whatever you have to do. Memorize them, but I would encourage you not to memorize them, to use that examples. If there is no less than $100 in my bank account, if there's no less than $100 in my bank account, that means I could have over that. First things you're going to be asked to do is be given a sentence, and then you're going to write the inequality. A number W minus 3.5 is less than or equal to -2. And we are just going to write the inequality represented by that statement. Break it down. I've got a number W minus 3.5 is less than or equal to -2. I've just wrote the statement. Three is less than a number, we'll call that number n, plus 5. And again, we just want to break it down. 3 is less than a number n plus 5. I've got 3, I've got my symbol, a number n, and plus 5. 1, 2, 3, 4 parts of it. Pretty straightforward. Zero is greater than or equal to twice a number x plus 1. I'm going to go ahead and box this one in. 0 is greater than or equal to, that takes care of that, twice a number x, that is just 2 times x plus 1, and I got it. Those are pretty straightforward, and they should be reviewed. Break them down, step by step, write the inequality. Little definition here, actually it's quite a big one, but it's important. A solution of an inequality is a value that makes the inequality true. An inequality, scrunch that in, an inequality can have more than one solution. All potential solutions, is called a solution set. I'm going to underline that word, solution set. So let's think about this for a second. A solution of an inequality is a value that makes the inequality true. How did we check equations? Get the question all the time, we'll solve equations. Mr. DeLong, is this right? And I will say, I don't know. How do you tell? And most students can tell me, well, I need to plug it back in. We need to do the same thing with inequalities. If I have something, for example, that is x is greater than or equal to 4, give me some values that are greater than or equal to 4. Well, 5 is. Isn't 6? Isn't 6.1, 6.2, 6.3, 8, 9, 10? Isn't any number that's bigger than 4 going to work for x? Certainly is. I'm going to it satisfies the equation. It is a solution for it. Any number will work that is bigger than 4 here. And it's called a solution set. You would see this written with some brackets, and we are not going to get into solution sets that much. You will definitely use them the farther along you go in math, but I've got these little brackets here. This would be x, then there'd be a line there, and we would just say x is greater than or equal to 4. And then I just have my bracket on the other side. All this is saying is that you are including every value in this solution that's bigger than 4. There's an infinite number of solutions for that. This is just a fancy way of writing it. I'm going to flip my paper. Here's how we use them. Tell whether -4 is a solution. And I'm going to give you a couple of inequalities here. First one, x plus 8 is less than -4. Let me clean that up a little bit. X plus 8 is less than -4. And we want to know whether -4 satisfies this inequality. Is it a solution? Well, just like we wanted to check our answers with equations, if I simply plug that back in and then evaluate the inequality, I'll be able to tell. This becomes -4 plus 8, and I want to know, is that less than -4? I got to make a comparison here. -4 plus 8 gives me a +4. Is +4 less than -4? Just read it. Once you plug it in, just read it. 4 less than -4. That is not true. That's false. Here's that symbol for therefore again, the triangle dots. This statement is false. Therefore, we can say -4 is not a solution. Doesn't work. When I plug in -4, I don't get a true statement. It's false. -4 is not a solution. That does not satisfy the inequality. When I plug it in and add it to 8, I get 4 is less than -4. It's false. It ain't no solution. -4.5x is greater than -21. And I can see right now, if I take that -4 and I plug it right into for x, I'm just going to substitute it in. And I can tell right away that this is going to be true. I don't even really care what negative 4.5 times negative 4 is. I know that a negative times a negative will give me a positive, and isn't any positive number going to be greater than negative 21? Certainly is. Negative 4.5 times 4, though, would be 4 times 4 is 16. Half of 4 is 2. 16 plus 2, 18. And it's positive. So I would be left with that statement there. 18 greater than negative 21. That's true. Positive numbers are always bigger than negative numbers. That's true. Therefore, negative 4 is a solution. Negative 4 is a solution. Why is it a solution? Because when I plug it into the inequality, I get a true statement. Graphing inequalities. And again, all of this should be reviewed, except for that part on solution sets. But that's just a fancy way of saying I'm including all numbers that satisfy it. X is less than 3. We're going to put these on a number line. I'll put 3 in the middle. I always want to get a couple numbers above and a couple numbers below on my number line. That's as fancy as the number line needs to be. Couple numbers above, couple numbers below. We want to graph it. And if I remember, when I'm graphing inequalities, it looks like this. And here's some things to point out that review. I'm looking for x's that are less than 3. It doesn't include 3, so it's an open circle. Open dot. We'll call it an open dot. With an open dot, inequality. Does not, the inequality does not have, and we'll say an equal sign. It's not an equal sign, it's just the line under. But we don't want to include the number 3 because this inequality, it can't be 3. It's not including it. It is numbers less than 3. So I draw my arrow to the left because I'm concerned with numbers less than 3, not including 3. And if you do remember this trick as well, when this is less than, this arrow is pointing to the left, my arrow is always going to follow what that's going. This is to the left, my arrow goes to the left. Versus x is greater than or equal to 3. And again, I'm going to just make a simple number line. 1, 2, 3, 4, 5. Couple numbers above, a couple numbers below. The number that I'm going to graph is 3. Now it is a closed dot because it includes the number 3. It has the equal sign. It's colored in. Closed dot or closed circle, whatever you want to say. I want x's that are greater than or equal to. Well, numbers that are greater than 3 are to the right. Again, my arrow would follow where this arrow is pointing. This is what my graph looks like. Numbers to the right of it. Graph, and we'll say x greater than or equal to 5. Here's as quick as I can do this. 5, 6, this is 4, 3, 7. It's going to be a closed dot at 5, and I want numbers that are greater than. It's going to follow the arrow. My arrow's pointing to the right. It's that right there. It's as easy as that. Looking at your number, open or close circle, then drawing your arrow. That's it. You are also, though, going to be given problems where you need to write the inequality. So you're going to be given the graph. I'll just make that. I will put an open circle here at -1, and I will draw this arrow to the left. Here's -1. It is going to be an open circle, so I know it is going to be a greater than or less than. What is it? I am concerned with numbers that are less than -1. I want x's that are less than -1. And if you went to graph this, you would plot -1. It'd be an open circle. Numbers left, they match up. That's how I do it. We are going to look at solving some inequalities now. And the only thing that we're going to look at today are ones that are dealing with addition and subtraction. W plus 6 less than or equal to 2. We solved these just like this was an equal sign here. If this was an equal sign right there, and I wanted to get W alone, I would subtract 6 from both sides. We want to treat this just like an equal sign. I will subtract 6. W then is less than or equal to 2 minus 6 is -4. W has to be less than or equal to -4, and you can certainly plug that back in. -4 plus 6 is 2. 2 is less than or equal to 2. Well, it's not less than 2, but it's equal to 2. And it makes sense that if I keep going in the negative direction, I want W's that are less than -4. The next number less than -4 would be -5. If I plug -5 in, that's going to give me -5 plus 6, 1. 1 is still less than 2. That's going to work. Choose something bigger than -4. What's something bigger than -4 and easy to work with? I'm going to just say 0. If W was 0, 6 less than or equal to 2. That ain't true. I need numbers that are less than -4. That's how we solve inequalities. You still will combine like terms and get the variable by itself. Last example. 4 is less than or equal to 6a subtract 4a minus 2. I treat it just like an equation. Just like an equation. And in section 1.2, when it said when I had an equation and I had a multi-step, first thing I want to do is simplify both sides. Even though this is an inequality, we're going to treat this just like an equation with an equal sign. I see I have some like terms to combine here. I have a 6a minus 4a. 4 is less than or equal to 6a minus 4a is a 2a subtract 2. Now, I need to get that a by itself. I will add 2 to both sides of the inequality. 6 is less than or equal to 2a. A is being multiplied by 2. I would divide both sides by 2. 3 less than or equal to a. And I'm done. I am going to have you rewrite these though. We are going to do what's called order the relation, which I'm always going to write my variable on the left. I need to flip this. A greater than or equal to 3. I just flip it. I flip it around. Right here, if I look, that symbol is opening up to the A. When I flip it, it needs to open up to the A here. This is the answer I'm looking for. And we will get better at ordering these relations as we go on. But the main thing I want you to concentrate on today is combining like terms and treating this just like an equal sign to get that variable by itself and get that inequality by itself. This is the top of 2.2, practice B. That's there. Hope that helps.